One of the means by which astronomers find the distance from Earth to some of the distant stars, one of the methods is called parallax, and I wanted to try and demonstrate that here in the laboratory. First of all, what I want to do is to try and find the distance between this ruler and this retort stand. Now, the way in which I'm going to do that is to have a look at the angles that are involved. So what I've got here is a protractor that's positioned at the end. So this is at the start of 1 metre. And what I'm going to do is line this up so that I can get the angle at which I have to look at that retort stand in order to be able to see it. So what I'm going to do now is line this up and mark the angle. So you can see there a little mark, and it looks close enough to 70 degrees, or at an angle here of 20. So I'll now move to the other end of this 1 metre and again have a look at the angle that's involved. So I've got that in position now, and you can see that the protractor is lined up with the ruler. What I've now got to do is have a look to see where the retort stand is, and there it is there. So what I'm going to do now is again line up the angle, or work out the angle at which I have to look in order to be able to see it from right at the end of this 1 metre length. So
So there I've made a little mark, and again that is close enough to 110, as you can see there, or if you like 70 degrees from here, the angle with the ruler. So that angle there is about 70 degrees. What I should be able to do now, given this distance here is 1 metre from here to there, and the angles that I've got, so this one here is 70 and the one down here was 70, I should be able to work out how far it is from this ruler to the retort stand. And what I'm going to do now is first of all measure it, then calculate it and see how close I am.
So I've measured that now to be 1.65 metres. 1.655 metres. I'll do the calculation and we can compare the two results. This is the situation that we've got. Here's our ruler of 1 metre, which means half that distance is 0.5 of a metre. We're interested in this distance D here to the retort stand. We've got an angle here of 20, maybe that should be 21, but anyway, in order to find D, if we what we can do, of course, is get the tan of this angle. So tan 20 degrees is equal to 0.5 divided by D,
So D then is equal to 0.5 divided by 1020, and put that into our trusted calculator. 0.5 divided by 1020 equals 1.37. Now that, of course, is a good deal different. Well, a good deal different. It's different from the measured figure that we had around 1.6. When that does happen, when we do get a difference like this, one of the things that we need to do then is to have a look and say, well, why? One of the reasons I would suggest is the measurement, the accurate measurement of these angles. So it's within some sort of reasonable level of accuracy here. That figure that we measured at 1.6 whatever, that is quite an accurate measure, and this is doing this via parallax.
The reason for doing all this, of course, is to find the distance from Earth to stars that are relatively close to our galaxy, the Milky Way. So what that really involves is looking through space to very distant objects. So let's have a look to see how that works by looking at a distant object that's a good deal far away from the college.
So here we are looking out of the back of 336, and we're focusing on this tower, which you can now see in the centre of the screen. But on its right, notice the little tree. Well, it's probably a big tree, but it's in the distance of the background. Now we'll go across to the other side of the laboratory and focus again on the same tower and tree. And this time you'll notice that the tree seems to be on the left-hand side, the left-hand side of the tower. So there it is there, just on the left. So it's moved from the right-hand side across to the left, or if you like, the tower has moved. So what we can derive from that is the angle. And in this next screen you will see a little bit more carefully me showing you what we're having a look at. This picture here shows you, first of all, the top one shows you the final picture, final position, and the one underneath shows you the initial position. So it's seemed to have moved from the right across to the left. What that gives us then, or enables us to give us, is an angle. But that angle is so small that even a protractor, our best attractor here at the college, we couldn't get a measure of that small angle. And that's the big difficulty with these, the parallax measure. Now here you can see what is the application of this method. It's in the bottom left-hand corner. You can see a picture of the sun and the Earth that moves around it. So the baseline here is in fact 2 astronomical units, 2 radii of the Earth going around the sun. We're looking then at the far away star, and there's a background there. What we see is the apparent movement of the star in the foreground. With the Hubble telescope, which is the telescope that's used by NASA to get these photos, the Hubble telescope is actually able to measure those angles. So the Hubble telescope can use parallax to find the distance then to some of those closer stars.